Binomial distribution. Binomial distribution is a discrete distribution with two possible outcomes only in a series of experiments. Those two possible outcomes would be success and failure. It is a distribution of a discrete random variable which represents an experiment with only two outcomes over a number of trials. So the binomial distribution probability mass function is p of x given n comma p, where n represents the number of trials, p represents the probability of success, which is equal to ncx multiplied by p power x multiplied by 1 minus p power n minus x, where ncx can be computed as n factorial divided by x factorial multiplied by n minus x factorial. As I mentioned before, n is the number of trials and p is the probability of success for every trial. Since p is the probability of success, automatically 1 minus p becomes the probability of failure. By considering this, we can say there are three assumptions we have with binomial distribution. The first assumption is each trial of the experiment results in one of the two possible outcomes. Those are success or failure. And the second assumption is the probability of the success is same for each trial. That means the value of p is same for each trial. And the third assumption is all the trials are independent. That means the result of one trial does not influence the result of any other trial. Now we will implement a function p of x to compute the probability density of the given x by using the Python. Let's get started. First we need to import the math module, which is the inbuilt module in Python. For that I am using the import statement. And then I am going to define the function to compute ncx value. See, this is the function I am using, ncx. Note that where capital N I am using, which will take two arguments. The first argument is n value, that is the number of trials, and the second value is x, which is the input value to compute the probability density. And then I am computing n factorial divided by x factorial multiplied by n minus x factorial with the help of a factorial function available in the math module, and this function returns that computed value. Next we need to return the probability density for the binomial distribution at the given x, for which I am going to define a function dbinom. I am using the dbinom as the name of this function because our programming language is having the same name to return the probability density for the binomial distribution at the given x. To have some resemblance, I am using the same name here also for this user defined function in Python. And this function will take three arguments. The first argument is the x value, and the second argument is capital N, which is nothing but the number of trials, and the third argument is the p value, which is probability of success, and returns a product which is nothing but the product of ncx, p power x and 1 minus p power n minus x, actually which computes the required probability density for the binomial distribution at the given x. So finally we got dbinom function which returns p of x value for the binomial distribution at the given x. Now there is a problem at our hand. A fair coin is tossed 5 times. What is the probability of getting 4 heads? If you observe the problem statement here, it is a fair coin. Fair coin means probability of getting heads is same as the probability of getting tails. Then the probability of heads is nothing but the probability of success if we consider. Then its probability would be 0.5. Since we have tossed that coin 5 times, the number of trials would be 5. Then we need to get the probability of getting 4 heads. That means here the x value is 4. By considering this statement, I am going to call the dbinom function with x value 4, the number of trials n is equal to 5, and the probability of success p is equal to 0.5. Then the probability from the binomial distribution would be, sorry I did not run the previous cells here, I have to run these two cells. Now I am running this cell. So I got 0.15625 as the result of this binom function, which means there is a 15% chance of getting 4 heads if you toss a fair coin for 5 times. So next one, fair coin is tossed for 10 times. Then what is the probability of getting 1 head, 2 heads and 3 heads? So here the number of trials is 10 because the fair coin is tossed for 10 times. Since it is fair coin, the probability P is equal to 0.5, no doubt in it. Then we need to find out the probability for the binomial distribution at x is equal to 1, at x is equal to 2, as well as at x is equal to 3, getting 1 heads, 2 heads and 3 heads respectively. For that I am going to give you a code snippet here. Here I am taking x as a list with 1, 2, 3 as values in it, and then I am using the list comprehension to get the t binom value of x with number of trials n is equal to 10 and the probability of success p is equal to 0.5 for all the values in x. Then automatically p will get a list of 3 values in it. The first value of that list p is nothing but the probability of x is equal to 1, that is this one, and the second value in that list is nothing but the probability of x is equal to 2, and the third value is nothing but the probability of x is equal to 3. Now I am running this cell. See here I got probability of getting 1 head is around only 1% and probability of getting 2 heads is around 4% and the probability of getting 3 heads is around 11%. So next we have another problem with our hand. Now I am considering a biased coin instead of a fair coin. If it is a fair coin, obviously the probability of getting heads is 0.5. But since it is a biased coin, we got some other value for the probability of getting heads, that is 0.4 in this case. That means the probability of getting tails would be 0.6. So obviously the total probability should be 1. And that biased coin is tossed for 100 times. Then what is the probability of getting not more than 45 heads? Not more than 45 heads means we need to find out probability of x less than or equal to 45. Now I am going to find out this probability, which is called as a cumulative probability. Why it is called as cumulative probability? Because we are going to find out the probability of getting not more than 45 heads. So it is the sum of probabilities of getting 0 heads to 45 heads. Then we will compute this with the help of dbinom function as well as Python built-in sum function. See here, I am considering x as a range object with the values from 0 to 45. You know 46 is the end value which is exclusive in that range. Then x will get the values in that range object from 0 to 45. We need that. And then I am using a list comprehension here with the number of trials n is equal to 100 and the probability of getting heads is 0.4 since it is a biased coin as per the problem statement. Then we will get P as a list. In that list, the first element is nothing but probability of getting 0 heads. The second element represents probability of getting 1 heads. And the third value represents the probability of getting 2 heads. And the last value represents the probability of getting 45 heads. If I find sum of all those probability values available in P, I will get cumulative probability. Then I am going to display that cumulative probability, which is nothing but P of x less than or equal to 45 by using a print function. If I run this, then I got the cumulative probability as 0.86. That means there is a probability of 87% to get the number of heads not more than 45, which is the way of calculating cumulative probability. So that's all guys. This is the end of implementing binomial distribution function in Python language.